Welcome back to Nature of Code in Rust and GGEZ. We're moving on to the next exercise, which is exercise I.5. Gaussian random walk is defined as one in which the step size, how far the object moves in a given direction, is generated with a normal distribution. Implement this variation of our random walk. All right, so that's what we're going to do today. Now, I've already copied over our template, and I've set up our cargo to toml to have rand and rand dist_r. So let's go ahead and get ourselves going here. What I'm going to do is continue to have our graphics clear here. So that way we won't get any of the weird flashiness that we were getting in the last video. So because of that, we're going to have a little bit of a different way of storing our points. We're going to use that the same vector. So maybe we'll have like maybe like steps, and that can be a vector of it's going to have to be the XY coordinates, but this could really just be the point 2 from mint, which is itself we're going to hold F32s. Besides that, we're going to need to create lines between each of these places. So we're going to want to have a mesh. Now, that being said, we're going to need meshes from like maybe we should have like a vector of meshes. That might make the most sense. If we have a vector of meshes, these are going to be lines essentially. So we're going to like have our starting position, and then we're going to have like our next position, create a line between, before and later. So we could have our X, which is an F32, a Y, which is an F32. Then we'll create a point from a line from the current X and Y to the next X and Y, throw that into our mesh, and then we'll loop through all of our meshes and then draw them out. I think that might be the best way to go about this. So let's go ahead and get set up here. We're going to have let our steps is going to be equal to an empty vector. We're going to have our X and Y, which is going to be equal to, we're going to need this to be the center of the screen is where we're going to start. So have context, remove that underscore, and we're going to do a graphics drawable size. All right, so our X is going to be the width divided by 2, and the Y is going to be the height divided by 2. All right, so that should give us everything that we need. We'll import that so Rust knows what this is. And let's go ahead and write our update now. So we have our like initial point here, our initial like location of where we are. Well, we're going to create a new one in update. So have let next X is going to be equal to, oh, you know what? We need our random number generator. So RNG, which is going to be that thread range. And we're also going to need our like step RNG, which is going to be a normal of F32. Okay, RNG is equal to thread G, and let step RNG equals to normal. What do you need? Oh, right, the 2 arguments. So Now, the exercise doesn't say what our mean and what our what we should be setting up for this. I'm thinking we want something between probably not like 0 is probably the mean, so we can have 0.0 as our mean, and our standard deviation of error. So the deviation is the square root of the average of sort of like distances away from the mean. So if we say something like 1, maybe let's do like 2, then it'll be a little bit easier to see. 2.0. And we store these away. Okay, so we have all these. Okay, so next x is going to be our step RNG dot sample, pass it mutable reference to self.rmg. That's going to give us like a number between essentially like negative something and a positive something. And we can do the next y is the same exact thing. Okay, so now we have the points essentially of like where we're going to be heading towards next. Time for us to create the mesh, which is going to be the line of where we're going. And what are you upset about? Expected. Oh, right. We need to unwrap you. All right, so time to create our line. This is going to be a mesh builder. And I think we can create a line here. So points, what do we need here? It's just going to be an array of point, probably a mint2 point. So we'll need 2 of those. And looking at this here, it's an array of these points. I wonder what would happen if I actually switch this around. Let's actually have these be a vector of point again. If we do that, and then I just draw this out, like create the single mesh with all these points, and then draw that out. So that would, okay, we have like our current x and y. Then I don't even need that. What we can do is create our x and y here, and we're gonna do a steps.push. So we're gonna need to make this mutable. And we're gonna put a point to the x and the y in here. And then no x and y for you. Now all we want to do is create our next x and next y. These can actually just be put directly inside of a point, automatically. So let's just go ahead and redo this a little bit. We're going to do a self.steps push, and we're going to have a point 2. Our x is going to be self.steprng.sample. There's for that, and then we'll have a y. Okay, and that's going to just push a brand new point in, and then we're going to want to have a mesh, a single mesh that goes over these steps. And we'll be updating that every single one of these frames. Let's see. How do I want to do this? I could create a mesh right now over these points. I actually don't know if it'll work with 0 points altogether. But let's go ahead and try. So actually we need to do a new first. Then we can do our line. We're going to take in a reference to these points. That will be a reference to the steps. And then our width, let's make this 2.0 width. And then our color, let's make this white. And we'll unwrap you and then build, hand it the context and unwrap that. Oh, it doesn't hate that. So let's go ahead and add in our mesh. It should be pretty much an empty mesh, but it's going to be much more interesting down here, where we're going to say self.mesh is equal to, we'll do another mesh builder, new line. Okay, this is going to be a reference to self.steps. Our width will remain with 2.0. We'll stay with white. We can just question mark this because we're returning a game result. Actually, we can do that same thing up here, can't we? Question mark you and you get question marked here. You can go back up there. That's okay. Okay, so then we're gonna build and the context, question mark that. We're good to go. Give it the context. All right, so that updates the mesh. And then what we want to do is we want to just simply draw that mesh out. I didn't pull in drop param. Okay, I just need the default drop params. I'm not going to overwrite any of it. And there we go. Let's go ahead and see what this ends up looking like. Oh, crash here. Okay, so mesh builder polyline got a list of less than 2 points. Okay, so it looks like we can't actually do a mesh unless we have 2 points. So let's go ahead. I still like the idea of having this mesh being built for us out here. Instead, what I'm gonna do is have an option that's gonna hold a mesh. And an option in Rust, if you're not familiar, is allows Rust to have basically a null or a void or a nil or whatever type of like doesn't have a value. You might hear a lot of people saying that Rust doesn't have nulls. They do kind of, but because it's in this option type, the compiler is able to force developers to handle these nulls, and that's the big difference. And it might feel like it's small, but it's actually a pretty big thing here. So I can set this mesh is really a none and set it equal to there. Now here we can say self.mesh is going to be equal to a sum of this. So now it has something in there. Now we can't draw this anymore because we don't have access to the mesh. So what I'm going to do is I'm going to say if let sum mesh equals reference to self.mesh. And this is one of the ways to sort of extract out of the option and like handling that null case, because if there is none, we're just going to skip whatever code is inside of here. So then we'll graphics draw, hand it the context. We could just hand it this mesh and then run our draw param. Let's go ahead and take a look at, does this work? It does work, but that line is absolutely huge. On top of that, that's going from, you notice that it's starting here in like the center and then like going over there, doing some stuff. Well, I think what's happening here is in our update loop, we're just getting this random sample. But we really want to probably add this onto the very last one, like the last point. And then that's where it's gonna go. So it's actually, let's do this in like 2 steps. We can do like a next. Oh, do we need to really do this in that? What we want to do is we want to take our random number that we grid here. We want to add it to the last x. So we need let's see, self.steps of position. Let's actually get the last position out directly. And we can just get a reference to it. That's just fine. So we'll do let last location is equal to a reference to self.steps and position self, because I don't think there is like a last. Oh, there is a last. If we take a look at what last is, returns the last element of the slice or none if it's empty. Notice it's going to give us an option here. So, well, that's interesting. Now we know that there is definitely something in here because we put something in here. We push that in. So I can just unwrap this. It's going to crash if that doesn't work. Also, I have this double %. I don't need this here. It's going to give us a reference to this point. This unwrap is going to crash the system, and it's me as the programmer saying, I understand, yes, if this is empty and there is no last element, go ahead and crash. Let's see. Then I want to add our last location.x, add last location.y. So if we do this, we should be constantly like changing our relative location, not like resetting back to something near 0, 0. Let's try it again. There we go. And now we're moving around this random step, and I have the old random step running for a while here. You'll notice that looks a little bit different when compared. This looks like little tiny lines, there's little jagged edges to it. It's actually sort of pretty cool, sort of seeing that come together like this. We could make some changes to it, like changing our standard deviation from like 2, we can make that 10, and it'll be really big steps. Let's also take care of this one warning that we have. Cannot borrow self.steps as mutable because it's also borrowed as immutable. Okay, so self.steps.push, right. So what we probably will really want to do here is do this in 2 different steps. So we're going to do let like next x is equal to, and then that's going to be this. Let next y is equal to this. And then we'll just have our x and y directly pulling in here. And are you going to have the same? Oh, cannot find. Yeah, you're going to be next. Oh, right. And you have to be x colon and y colon. And that makes it a lot happier. So that is something we run into with the compiler a lot, is it's just suggesting to us that, hey, there could be problems here if you're trying to do it the way you're doing it, change the order around, and there's just no possibility of a problem. So let's go ahead and run this again, but this time with a new standard deviation, and we'll see the steps are really much longer and looks a lot cooler now too. Now, if I wanted to add colors in or something else, then I would need to like have multiple meshes to have different colors. Otherwise, we'd be updating the entire lines all at the same time. Anyways, that is exercise I.5, Gaussian random walk. Thanks for watching, and I'll see you in the next video. Bye.